All right, so next example, again, example number 4 here. We want to find the exact value of the tangent of 22.5 degrees. So this needs to pop back up. There it is. So that puts our target angle, and I don't know if this is going to be smart. I think so. If the target angle is 22.5 degrees, just to know without a shadow of a doubt, that's the angle that we care about. That's the angle that we're approaching. Now, that target angle of 22.5 degrees obviously is not one of the 16 that we know from the unit circle. We don't have the ability to evaluate the sine of, or excuse me, the tangent of 22.5 degrees the same way that we could evaluate the tangent of, say, 30 degrees or 60 degrees or 180 degrees or whatever it is that we do know from the unit circle. But what we do have in mind, what we do know, is that if my task is to find the tangent of 22.5 degrees, I know that that is equal to the tangent of 45 degrees over 2. That these are exactly identical, that 45 over 2 is equivalent to that target angle of 22.5 degrees. And obviously the reason why it's advantageous for us to make that jump is that as soon as we have it written out in this format, using 45 degrees as angle u or theta or whatever it is that we want to incorporate, what we know moving into, again, now I'm just pulling this directly off of our notes or off of our formula sheets, that if we have the tangent of theta over 2, that's going to be equal to 1 minus the cosine of theta over, oops, no, I'm getting my formulas mixed up here, 1 minus cosine of theta over sine theta, and that's also equivalent to the sine of theta over 1 plus the cosine of theta. Now, again, we do not have to use both of these formulas. We can use whichever one we would prefer. But everywhere that I see a theta, we're going to set this up to where theta is equal to 45 degrees. We know that this is going to be our substitution angle because that's the one that we know from the unit circle, and we can go to work. Okay. Now, I wrote this up using thetas again, frankly, out of habit. In the note packet that you all received, it says tangent of u over 2 is equal to 1 minus cosine u over sine u, and so on. Again, and I try to stay consistent with the textbook there, but again, I guess my own habits are creeping in. So, first decision that we need to make is which of these formulas do we want to use? Do we want to use 1 minus cosine theta over sine theta, or do we want to use sine theta over 1 plus cosine theta? And while it doesn't really matter in the sense that we're going to get the same correct answer either way, again, I guess the advantage that I have moving forward is the fact that I've done this problem before, and I think it's going to feel a little bit easier to utilize this first. So for that reason, I'm going to go ahead and drop that second. And now when we rewrite this, virtually the exact same thing, but everywhere that I see a theta, I'm going to instead insert 45 degrees, because we said theta, again, is equal to 45 degrees. So the tangent of 45 degrees over 2 is equal to 1 minus the cosine of 45 degrees over the sine of 45 degrees. Now, where we need to begin, because, again, in many ways, we could kind of, I like to say it this way, as you're well aware, in many ways, we could say that the pre-calculus is really close to being finished. We do need to evaluate. We do need to find what is the cosine of 45 degrees, and using the unit circle, our knowledge, we know that the cosine of 45 degrees is going to be the square root of 2 over 2. That's over the sine of 45 degrees, and we know that the sine of 45 degrees, that is also root 2 over 2. So now at this point, I think that we could really make that argument that, yeah, pre-calc it's essentially finished. So looking at my numerator, I have 1 minus root 2 over 2. I need to combine those. So I'm going to leave my denominator the same, root 2 over 2 for the time being. And in the numerator, where I have 1 minus root 2 over 2, all I'm going to do is I'm going to alter this 1 as 2 over 2. Now I have common denominators, and I can actually subtract those. So up top in the numerator, if I have 2 over 2 minus root 2 over 2, when I combine those numerators over the common denominator, it's going to start to look something like this. And keep in mind that my actual denominator, root 2 over 2, is haven't touched it yet. So hopefully the color coordinating is making some sense here. But yeah, this is absolutely where we are at, for the time being. I'm sure that you can predict the next question that I would typically ask. When we divide fractions, what are we really doing? Well, obviously, what we're really doing when we divide fractions is we multiply by the recipient. So when I'm dividing by root 2 over 2, that's the same as multiplying by 2 over root 2. Now, please be incredibly careful when the time comes to multiply and have cancellations and things like that. I'm going to overdo this problem a little bit, quite frankly. If we were to multiply the numerator, this is what it's going to look like. Over the denominator, this is what it's going to look like. And at this point, yes, there are some cancellations. These 2's are going to cancel. These root 2's are not going to cancel. Again, that root 2 is part of a binomial. So what that puts me with is we have 2 minus root 2 all over root 2. Again, hopefully as, no shock to anyone, we know that we cannot leave a radical in the denominator. So what we're going to choose to do is we're going to rationalize by multiplying the denominator times root 2. The only way that we get away with that is if we also multiply the numerator by root 2. So in the denominator, the whole reason for doing this, root 2 times root 2 is positive 2. But in the numerator, when I distribute, root 2 times 2 is going to give me 2 root 2. Root 2 times negative root 2 is going to give me negative 2. So we've got a lot of 2's going on there. And when I look into the numerator, we could actually factor something out. We can factor a 2 out of this whole thing, leaving me with root 2 minus 1 over 2, at which point we can see that cancellation is going to occur for my final answer of root 2 minus 1. Again, in many ways, I prefer that we actually write it as negative 1 plus root 2. This way we have no doubt whatsoever where that radical begins and ends. And we don't want to accidentally think that's the square root of 2 minus 1, all under the radical, that sort of thing. So, again, to be clear, this would have been completely acceptable. All right, so again, hopefully we're making some sense out of that half-angle formula. Again, as we finished up the previous, I would say that the biggest key is to understand what is my target angle and how did I get there. So if my target angle is 22.5 degrees, I know that that's not on the unit circle, but it's exactly half of 45 degrees, which is on the unit circle. So the other problem that we wanted to circle back and make sure that was on the video was actually before the half-angle formulas, and it was example number 2, dealing with the double angle formula. So in class yesterday, we got through this problem in its entirety, 7th period, but not quite in its entirety during the 2nd period. So I do want to make sure that we get this one on video. So we want to use the following to find sine 2 theta, cosine 2 theta, tangent 2 theta. And as we talked about yesterday, typically you're not going to be asked to do all of these. Usually it would probably just be one. So sine of 2 theta, cosine of 2 theta, tangent of 2 theta. This is our task. We're told, quite luckily, that the cosine of theta is equal to 5/13. We're also told where theta resides. We're told that it's going to fall between 3 pi over 2 and 2 pi. So the issue that we have ahead of us is just using the double angle formula. The double angle formula for sine, we know that's equivalent to 2 sine theta cosine theta. Now, the good news is that if we're given that cosine theta is 5/13, we know exactly what we're going to put in place for cosine theta when the time comes. Bad news is we have no idea what we're going to put in place for sine theta. Same story over here on the tangent. Tangent, we know that tangent double angle formula is going to be 2 tangent theta over 1 minus tangent squared theta. And at this point, yeah, I'm given cosine, but I have no idea what tangent is. Okay, so we've got some work ahead of us. Cosine double angle, again, if we're smart, we could actually pull this one off. We do have 3 options when it comes to using the cosine double angle. But if we use that middle option of 2 cosine squared, 2 cosine squared theta minus 1, since we know what cosine is equivalent to, we know that cosine is 5/13, we can actually be successful in solving this. So let's go ahead and knock that one out first and foremost. So if we were to clean this up, we have 2 times. Now when we square a fraction, we have to square the numerator and denominator. So 5 squared is 25, 13 squared is 169. 9. This is all minus 1. So remember that 2, that coefficient, that's over 1. As I multiply fractions, 2 times 25, that's going to give me 50. Over 1 times 169 is 169. Hopefully we're okay with me using this little cheat here. 1 is really just going to be 169 over 169. So if I were to look at this, 50 over 169 minus 169 over 169, that's going to lead me to be able to actually answer this question and say that that's equivalent to the negative 119 over 169. Okay, so we found the cosine double angle. Sine and tangent, though, we need more information. So luckily, they told us that the cosine was 5/13, and I could use that information to draw a triangle. But where do I draw the triangle? And that's where this piece comes in. We're told that theta is going to fall between 3 pi over 2 and 2 pi. If I'm looking at the unit circle, 3 pi over 2 is here, 2 pi is here. That's saying that from 3 pi over 2 all the way to 2 pi, that's where we have to live. Well, guys, if we look a little closer, that's the fourth quadrant. We know that we're going to have to draw this triangle in the fourth quadrant such that the cosine, the adjacent over the hypotenuse, is going to be 5/13. That's where theta is going to live, here in the fourth quadrant. So if I were to do my Pythagorean theorem, I'm going to get that this opposite side is 12, but since it's in the fourth quadrant, that better be negative 12. So as we said, when it comes time for us to use the sine double angle formula, I need to know the sine of theta. So using this triangle now, we can establish that sine, opposite over hypotenuse, is going to be negative 12/13. When the time comes for us to plug into the tangent double angle formula, we will need to know the tangent of theta. So using that same triangle, opposite over adjacent, negative 12/5 is going to be my tangent. So now for my substitutions, see those. Again, jumping back over here to the sine double angle, 2 sine theta cosine theta, 2 times, we know that in place of sine theta, we can put negative 12/13. While in place for cosine theta, remember that we were given that was equivalent to 5/13. So as we multiply that 2, again, it's really 2 over 1. So as I multiply straight across, 2 times negative 12 times 5 is going to be negative 120 over 1 times 13 times 13 is 169. That does not reduce, so we're done. So a little bit more work is going to be ahead of us here, just as forewarning for the tangent to theta. Again, not that we're going to approach it differently or anything like that, but again, it's going to feel like we have a little bit more work. So 2 times the tangent of theta. And we know the tangent of theta is negative 12/5. This is over 1 minus, get that out of the way for a minute, 1 minus tangent squared. And tangent, once again, is negative 12/5. All right, so as we continue on here, just can't get that thing out of the way here. As we continue on, as I clean up, let's go with the numerator here to start. Remember that 2 is really over 1. As I multiply in the numerator, we're going to switch this up and go red for the numerator. If I multiply straight across, that's going to give me negative 24/5 in the numerator. The denominator, we've got some work here, 1 minus. Now if I have negative 12/5 squared, as we said before, when you square a fraction, you're going to square the numerator, so negative 12 squared is 144, over square the denominator, 5 squared is going to be 25. All right, I promise you, I am writing this down as we speak, and it is not showing up.